have our Unit 1 practice test that we're going to go through. For number 1, we're going to write the definition for each type of angle. We're going to talk first about the acute angle. The acute angle is an angle, try to write small and neat, that's hard for me, an angle with a measure between 0 and 90 degrees. Between 0 and 90 degrees. So I'm going to go ahead and draw just a little quick picture of that for you. Here's an example of what an acute angle would look like. So it's less than 90 degrees, greater than 0 degrees. So next, a right angle is an angle with a measure of exactly 90 degrees. So exactly 90 degrees for a right angle, and an example of that would be an angle that looks like that. It has a little box in the corner to show exactly 90 degrees. We have the obtuse angle next. That's going to be an angle with a measure between 90 and 180 degrees. So greater than 90, less than 180, and an example of that would be an angle that looks like this. And then we have our straight angle, which is an angle with a measure of exactly 180 degrees. So exactly 180 degrees, and that looks like your straight line. Okay. Number 2, Bill named angle 3 using points by calling it angle F. So Bill named, it was flawed. Explain why angle 3 cannot be named angle F. So he was talking about angle 3 right here. So I'm going to go ahead and highlight angle 3. Okay, so here's angle 3. He could not call this angle F because there are several angles happening at angle F. Well, for sure there's 2 angles that have a vertex at angle F. So that is why we cannot call angle 3 angle F. So we're going to write that down. So there are 2 angles with vertex F. There's one here and there's one here. So by calling it angle F, so by calling angle 3 angle F, he was not specific enough. We don't know which one he's talking about. So he was not specific. So let's talk about what he should have said. So in order to name angle 3 right here, what I highlighted is, we can say he should have said, okay, when we name this angle, we are going to use a point from the side, vertex, a point from the other side. So an example of what he could have said was angle CFD. He could have said CFA. Remember, you use the little angle sign and then the 3 letters. Okay, and then going on this side, he could have said angle AFC or DFC. All of those would have been appropriate to name angle 3, but he cannot say angle F because there are multiple angles happening at that vertex, so that would not be good. Okay, number 3, we're going to find X given this information. So looking at this, we have to understand that these 2 angles are a linear pair or supplementary. They're forming a straight line, meaning they're 180 degrees. So this, I'm going to just go ahead and write down for you, is a linear pair. So the sum of the angles is going to be 180 degrees. So I'm going to add each angle. I have x plus 16 plus 5x plus 2 is going to equal 180 degrees. And then I'm going to combine like terms. So I have my x terms, 1x and 5x is 6x. Then I have 16 plus 2, that gives me 18. That's equal to 180 degrees. And then I'm going to continue to solve for x. I'm now going to subtract 18. 6x is equal to 162 degrees. Then when I divide by 6, I need to know how to do that math, so I'm going to do that over here. 162 divided by 6. 16 divided by 6 here gives us 2. 2 times 6 is 12. Subtract 42 divided by 6 gives me 7. So 162 divided by 6 is 27. So x is equal to 27. Okay. Number 4, they're asking us to identify 3 sets of collinear points. So we can remember that collinear means points that lie on the same line. So I'm going to go ahead and write that down. Points that are on the same line. So first, if we look here, I have a point over here at G. I have a point here at F and a point here for D. I'm sorry, F here. Sorry guys, I'm falling asleep. And F and D. So those are going to be our first set of collinear points because they're on the line, the same line. So I'm going to say set 1 has point G, point F, and point D. All right, then I have right here on this line, point A, point E, and point D. So that's going to form that line right there. Let me find another color. So this one is going to be A, E, and D. Those are on the same yellow line there. So I'm going to write those down. A, E, and D. And then for our last points that are on the same line that are collinear, we have point B, C, and D. So those are together on the same line. Those are collinear here on that blue line. So I'm going to name those D, C, and B. 3 sets of collinear points. Collinear points are points that lie on the same line. Okay, number 5, mine's on the back page here because I spaced these out, gave myself some more room. Okay, so we're going to talk about all of these vocabulary words. We're going to define them using drawing, symbols, words. All right, so starting with a linear pair. A linear pair is a pair of angles that form a line. So pair of angles that form a line. So I'm going to go ahead and draw that for you. Whoops. Over here. We'll draw it here. So if I have this happening, angle 1 and angle 2 are an example of a linear pair because those angles are going to form a straight line. So we have angle 1, and then when you put that together with angle 2, it forms that straight line. So that would be linear pair. Vertical angles are 2 angles formed by 2 pairs of opposite rays. Two angles formed by 2 pairs of opposite rays. So here is our first opposite ray, first pair of opposite rays, and then we have another set of opposite rays. Okay, so an example of these vertical angles would be up here at angle 1 and here at angle 2. So those angles, you can kind of say that they're opposite from one another across that common intersection. So those are angle 1 and angle 2, example of vertical angles. So next thing, complementary angles are a pair of angles or two angles whose measures add up to 90 degrees. So two angles whose measures add up to 90 degrees. And an example of that would be if I have, let's say this, angle 1 and angle 2, and they come together to form the 90-degree angle. The sum of those, angle 1 and angle 2, is 90, or they add up to 90 degrees. Supplementary angles are two angles whose measures add up to now 180 degrees. So an example of that would be, here's one angle, here's another angle, angle 1, angle 2, their sum is going to be 180 degrees, forming this straight line. Okay, midpoint. Midpoint is a point that divides or bisects the segment into two congruent segments. Two congruent segments, or two equal segments, or segments in equal length. So an example of that would be if I had this segment, we'll just call it AB. Okay, if we had right here in the middle, those, our midpoint M, that is our midpoint. And we can show that using this little tick mark here to show that these two segments are equal. So this entire segment was divided into two congruent segments. All right, ray. So for a ray consists of an endpoint. I'm going to go ahead and draw that for you before we continue this. So I'm just going to draw an example of a ray. I would have ray FG. So that's an example of a ray. So it consists of, definitely meant to say of an endpoint. In this case, F. So we have an endpoint F, and the line that extends infinitely towards G. So it's always going to have an endpoint and then a line that extends infinitely towards another point, in this case, point G. And then I'm just going to add in that if you wanted to write down the name of this, you would write it like this, FG, and then has that line, the arrowhead, going towards G here. So you put the little ray above the endpoint going towards the point G in this case. Okay, next we have our segment. Our segment consists of two endpoints and all the points that lie between them. So an example of that would be if I had segment AB. A and B are my endpoints, and then the segment includes all of those points that lie between them. Okay, an angle is formed by two rays with the same endpoint. So an example of that would be if I have a ray, so ray QR, and then another ray, so ray QS. So two rays that have the same endpoint. In this case, endpoint is Q. That's an example of an angle. All right, collinear is going to be points that lie on the same line. We talked about that a little bit before. Points that lie on the same line. So an example of that would be if we had a line and I'll just make two collinear points. So I will call that A and B. Okay. So those are 2 points on the same line. Those are collinear. Okay, moving on. So we're given that the measure of angle 1 is 10x minus 2 degrees. So I always like to write in the expression next to the angle so I can see it very clearly visually. So angle 1 right here is 10x minus 2. And then they tell us that angle 3 is 6x plus 50. Okay, so we need to figure out a relationship between these so we can solve for x. We need to set up an equation to solve for x. So these are what we call vertical angles. And vertical angles are congruent. So we're going to go ahead and set this angle measure equal to this angle measure. So to set up my equation, it will be 10x minus 2 is equal to 6x plus 50 because vertical angles, when they're opposite like this, those are congruent angles equal in measure. So I'm going to solve this by using my inverse operations. I'm going to subtract 6x to both sides and then bring down the rest. 4x minus 2 is equal to 50. And then again, inverse operations, I'm adding 2 to both sides. I get 4x is equal to 52. And then my final step to solve for x is dividing both sides by 4. 52 divided by 4, I'm going to go ahead and show the work for that. 5 divided by 4, that's 1. 1 times 4 is 4. 12 divided by 4 is 3. So 52 divided by 4 is 13. My answer is x equals 13. Number 7. Again, they're giving us this figure and this information. I'm going to go ahead and write it in as I read it to kind of make it more visual and more clear for me. So the measure of angle PQS, that means PQS, this angle here, is 8x plus 14. I'm just going to write that in there. 8x plus 14 is going to be our degrees. And then RQS is this angle. They tell us that's going to be 7x plus 24. And then they tell us PQR, so this entire angle, PQR, is going to add up to 83 degrees. So the whole thing will be 83 degrees. So what I have is my angle addition postulate that says this angle plus this angle will equal the entire 83 degrees. So I'm going to set that equation up, and then I'm going to solve for x. So I have 7x plus 24 plus 8x plus 14 is equal to 83 degrees. And then I'm going to go ahead and solve. So if I need to solve for x, I'm first going to combine like terms. 7x and 8x gives me 15x. 24 and 14 is going to give me 38. That's equal to 83. Solving for x, I'm going to subtract 38 to both sides. And I get 15x is equal to 45. And then I'm going to divide by 15. 45 divided by 15 is 3. So x is equal to 3. Number 8, we're going to let A be between B and P. We're going to use the segment addition postulate to solve for X. So given all this information, it's going to make my life easier if I just draw a visual. I always want to draw a visual if they don't give that to me. So let A be between B and P would look like this. Here's B, here's P, and then A is going to be somewhere between them. A is going to be between B and P. So then I'm going to take this information and I'm going to label my segment. So BA, meaning this segment BA, is x plus 9. So I'm going to label that x plus 9. AP, which is this segment here, is 4x minus 16. I'm sorry, 4x minus 6. And BP, meaning this entire segment, is going to be equal to 51. So using my segment addition postulate, I know this angle plus, this segment plus this segment equals the entire segment. So I'm going to create my equation like that. X plus 9 plus 4x minus 6 is equal to 51. And then again, I'm going to solve for x. I need to combine like terms. So 1x plus 4x will give me 5x. Then I have a 9, positive 9, negative 6 gives me positive 3. That's equal to 51. Then I'm going to subtract 3. 5x is equal to 48. And then my final step is dividing by 5. So x is equal to 48 over 5, which we can't simplify that fraction. So if you had a fraction, you would leave it. Or we can put it into a decimal if we do some division. So 48 divided by 5. 48 divided by 5. 5 goes in 9 times. 9 times 5 is 45. I'm left with 3. I can add a decimal and a 0. Bring down the 0. 30 divided by 5 is 6. So I can say 48 divided by 5, or 48 over 5, or 9.6. And that is my answer for x. Okay, number 9. The endpoints of segment AB are -1, -1, and B is 6, -3. We're going to find the coordinates of the midpoint. So remember, when you find midpoint, you can think of it as the average between the two ordered pairs. So we're going to find the average, essentially, of the x values and the average of the y values. So it follows the formula x1 plus x sub 2 divided by 2 for my first coordinate, so for my x in the coordinate, and then y1 plus y2 divided by 2 will give me the y for the midpoint. So here's my x1, x sub 1, y sub 1 for my first ordered pair, x sub 2, y sub 2 for my second ordered pair, and I'm going to plug those numbers here. So it's going to be -1 plus 6 divided by 2, and -1 plus -3 divided by 2. So again, -1 plus 6, those are my x values. I'm adding them and dividing by 2. Then I'm taking my y values, adding them and dividing by 2 to get my ordered pair for midpoint. So across the top here, -1 plus 6 is 5. And 5 divided by 2. -1 plus -3 is -4. And then we can go ahead and say -4 divided by 2 is -2. So the coordinates for my midpoint would be 5 over 2, or you could say 2.5, comma, -2. That's the midpoint. Number 10. We're given that the measure of angle P is 7x minus 5 degrees. Maria says that when x is equal to 26, angle P will be a straight angle. Maria's wrong, and we're going to explain why she's wrong. So first of all, we need to know what angle P is a straight angle means. So if she's saying that angle P is a straight angle, she is saying that angle P is going to equal 180 degrees exactly, because that's what a straight angle is. It equals 180 degrees. So, or it's an angle of a 180 degree measure. So what I'm going to do is I'm going to see what happens when I plug in x is 26 right here for x. So it will be 7 times 26 minus 5. So let's see what our degree would be for angle P. So it's going to be 26 times 7, and I'll go ahead and do that work here for you. 6 times 7 is 42. 14 plus 4 is 18. So I get 182. So we got 7 times 6 is 182. 182 minus 5 gives us 177 degrees. So that means the measure of angle P is equal to 177 degrees. So Maria's wrong, and we're going to explain to her why she's wrong. So we're saying that if we plug in 26, we get 177. So we need to explain to her that a straight angle is 180 degrees. Okay, so an angle P we found was 177 degrees when x equals 26. Okay, so our angle is 177. It's not 180 degrees, so that is why it is incorrect. So not good. 177. So we can actually just add in and let Maria know that that just means angle P is an obtuse angle, not a straight angle. It's obtuse because it's greater than 90 degrees, less than 180. Okay. Number 11, we're given that ray BD bisects angle ADC. So we need to remember that bisects is going to divide this angle in half. So this is going to give us two congruent angles. And I'm using those little arcs to show this angle will be congruent to this. So when I set up my equation, I'm going to take this and equal it to this. So 21x minus 24 is equal to 3x plus 48. And then I'm going to solve for x by moving this 3x, subtracting 3x to both sides, and I get 18x minus 24 is equal to 48. Then I'm going to add 24, and I get 18x is equal to 72. And I'm going to divide by 18. So x is equal to 72 divided by 18. We get x is equal to 4. And they just wanted us to solve for x. So we're done. Again, these are equal because of the word bisects telling us ray BD is dividing this directly in half to two equal or congruent angles. All right, number 12. We're given this triangle in the coordinate plane with the vertices. We're going to find the perimeter. So we want to remember that perimeter means we're going to add up all the sides in the figure. In this case, it's triangle. So I need to find all of the side lengths. So these are easy to find. We can go ahead and just count. This side length here is going to be 6. And then we have 7. And we need to be able to find this last missing side, the hypotenuse, in order to find the perimeter. And we cannot do that counting just the boxes. So I'm going to use the Pythagorean theorem because we can use the Pythagorean theorem, which is a squared plus b squared equals c squared. We can use that anytime we have a right angle with two of the sides. So what we're going to do is we're going to find this missing side x using Pythagorean theorem. But when we use Pythagorean theorem, we have to remember that the hypotenuse is always plugged in for c. So x will be plugged in for c, and then a and b go for the legs, and those are interchangeable. We'll just let a be 6 and b be 7. So I'm going to plug that into my formula. I got 6 squared plus 7 squared is equal to x squared. So I get 6 times 6 is 36, plus 7 times 7 is 49, still equal to x squared. And again, you guys, I'm solving for x so that I could find that missing side. So 36 plus 49 is going to give us 85. That's equal to x squared. And then my last step to solve for x would be to do the square root to both sides. X is equal to the square root of 85. So I know that this hypotenuse right here is square root of 85. So now when I need to find my perimeter, when I add up all these sides, it's going to be 6 plus 7 plus the square root of 85. So we can go ahead and combine these constants. 6 plus 7 gives us 13, but we need to leave our square root alone. You can't combine that with our constant. So you just leave your answer like this, 13 plus the square root of 85. Okay. Number 13, I'm going to find the area of the triangle. So I'm going to remember to find the area of a triangle, I use the formula base times height divided by 2. So my area is going to be base times the height divided by 2, or 1/2 base times height, same thing. All right, so I have to remember for the base and the height, it's always in a triangle, the two lengths that form a right angle that are, in this case, here will be our base. So 2, 3, 4. I know my base is going to be 8, and then my height is formed a perpendicular or forming a right angle with the base. Base and height are always the two that form a right angle in the triangle. So I'm going to count my height right here, and I get that my height is 5, and then I plug that into my equation. It's going to be base times height divided by 2. So 40 divided by 2, I get 20. So it's going to be, for my area, 20 units squared. Again, base times height divided by 2. Your base and your height are always going to be the two lengths that form a right angle. Okay. Number 14, we're going to find the length of this segment. So there's actually 2 ways to do this. If you would like, you could go ahead and identify the ordered pair for each of these. So this is going to be -5, 4, and this ordered pair would be 3, -2. And you can go ahead and use the distance formula if you feel comfortable doing that. I'll write that down for you. It's the difference in x's squared plus the difference in y's squared. You would just label x1, y1, x2, y2, plug them in. Okay, and then you would get your answer for your length. But I'm going to do it a different method. I'm going to use Pythagorean theorem. So I'm going to be using this formula. But remember, for Pythagorean theorem, you have to have a right triangle. So since I'm in the coordinate plane, I can easily draw that right triangle by dropping down this leg here and this leg here. So what happens is we just need to find the length of that hypotenuse in our right triangle, because if we find the length of the hypotenuse, we'll have the length of the segment. So similar to what we did in a previous question, I can find these missing sides just by counting. So this side length is 6. This side length here is going to be 8, and I'm going to take those numbers and plug them in so that I can find my missing x. So again, A and B are going to be the legs, and C is always the hypotenuse. So plugging in these numbers, I have 6 squared plus 8 squared is equal to x squared. So 36 plus 64 is equal to x squared. I'm going to add, and I get 100 is equal to x squared. And my final step, if I want to get x by itself, is to do the square root. Square root of 100 is 10. So I have that my missing length right here is 10. So that means that this segment that we were looking for, the length of GH, is 10. So segment GH is 10 units. And then if you would have used this method, you still would have gotten 10 as your answer. Okay, number 15. Angle 1 and angle 2 are supplementary angles. We're going to find the measure of angle 1 and the measure of angle 2. So we remember supplementary means the sum of the angles is 180 degrees. So I'm going to go ahead and write that out for us. We're going to have the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. The measure of angle 1, they tell me right here, will be x plus 50. Measure of angle 2 is x plus 100 equal to 180 degrees. So I'm taking the angles, I'm adding them, equal to 180. And again, I'm combining like terms. 1x plus 1x is 2x. 50 and 100 is 150. That's equal to 180. I'm going to subtract 150 degrees, both sides. 2x is equal to 30. And then my final step, dividing by 2, x is equal to 15. All right, so they did not tell me to solve for x. They told me to find the measure of angle 1 and find the measure of angle 2. So what I'm going to do is I'm going to plug in x back up here to these. So to find the measure of angle 2, I'm going to replace x with 15. So 15 plus 50 is 65 degrees. So I know the measure of angle 1 is 65 degrees. There's my first answer. Okay, to find the measure of angle 2, I'm going to take 15 and now plug it in here for x. 15 plus 100 is 115 degrees. So the measure of angle 2 is 115 degrees. Those are my two supplementary angles. All right, we're going to mark each diagram according to the given information. So we're talking about angles. Angle 1 and angle 2 are congruent. So to show that angles are congruent, we use these arcs. So if this angle has one arc and this angle is congruent to it, then you would also put only one arc. So that shows they are congruent. So however many arcs is in the one angle, you would put the same amount of arcs in the other angle that it's congruent to. All right, if they tell us that angle K is the midpoint of JL, then we know that JK and KL are congruent. So when you have a segment, you use this little tick mark, the little dash. So we put one dash for JK and one dash for KL, showing that JK is congruent to KL, or they have equal lengths because of the midpoint K. Number 17, we're going to find the value of x. So given this information, we're going to need to create an equation. So we have to look at that little box right there and know that that means that this angle is 90 degrees. So if this angle is 90 degrees, because this is a straight line, then we have to know that this angle over here, which I'm going to highlight, is also a right angle. So this is a right angle, meaning the sum of these angles here and here will equal 90 degrees. So it'll be 8x plus 3x plus 13 is equal to 90 degrees. So these two angles add up to 90. So again, I'm going to combine like terms and solve. 8x plus 3x is 11x. Then I'm going to subtract 13. 11x is equal to 77. Divide by 11. 77 divided by 11, I get x equals 7. And I'm done. They just wanted me to find the value of x. All right, number 18. Let me run and grab my Okay. So we're going to use the angles to answer the questions below. They want us to give the definition of complementary angles. Then we're going to state a pair of complementary angles and describe the steps that we took. So what I'm going to look at is all of these angle measures. If I'm talking about complementary angles, then I know that I'm talking about the sum of these angles being 90 degrees. So I'm going to use my protractor to give all of these angles measures. Okay, so when I look at my protractor, I'm going to line up the center there with the vertex. This 0 line is going to lie on one of the sides of the angle. And then if I'm starting at 0 on the right here, I'm going to look at my inside numbers. So I know that this angle has a measure of, up here, 60 degrees. So I'm going to just write that in here. This angle measures 60 degrees. Okay, angle 2, I'm going to measure again. Vertex is going to be on the center. And then the 0 is going to align with the side. And then I'm going to count inside the middle numbers over here to the other side, which is at 150 degrees. All right, next one, I'm going to line up on my vertex. This time, get rid of this. This time I have 0 on the left side on this side. So now I read the outside numbers. This is a 20-degree angle. And then for our final angle, again, lining up the vertex, this is a, starting at 0, 30-degree angle. So they want us now to give the definition of complementary angles. So complementary angles are a pair of angles whose measure adds up to 90 degrees. So what we're going to do is we need to look here to see what angles add up to 90 degrees. So looking here, I have 60 and 20, that only gives me 80 degrees. These would give me 50, 180. There it is. 60 plus 30, we know, gives us 90 degrees. So if I want to state a pair of complementary angles, then I would say angle 1 and angle 4. Those are complementary because their sum is 90 degrees. So to describe the steps we took to identify the complementary angles is that we measured each angle. So I'm going to say I measured each angle with a protractor. Then the two angle measures that added up to 90 degrees are 60 degrees and 30 degrees. And those were from angle 1 and angle 4. So that's why I said angle 1 and angle 4 are complementary, because they add up to 90 degrees. All right, good job, you guys. Good luck on that test. Make sure that you study through all of this stuff, especially the vocabulary words, and good luck.